Hello everybody, so this is chapter 4 video lecture, and it's likely going to take us 2 of these to get through, so keep that in mind. Alright, so you already know that for multicellular organisms that our cells come together to make tissues. So there is a common function of the tissue type. So we have 4 basic tissues in animals. We have connective tissue that connects other tissues together. Muscular tissue, which aids and actually is responsible for movement because of contraction of that muscle tissue. We have nervous tissue, which is responsible for rapidly sending electrical signals. And then the epithelial tissue, which is responsible for covering and protecting the outside of the body and lining the inside of our cavities. So let's start with the connective tissue. All connective tissue, whether we're talking about bone, cartilage, blood, and so on, has 3 components. There is the specialized cell. Okay, there are specialized cells in blood, red blood cells, white blood cells, for example. Specialized cells in bone, the osteocytes. Specialized cells in our cartilage, the chondrocytes. Then there is a ground substance. The one that's most obvious with blood is the plasma. We will talk about the ground substance of some other examples as we go through the slides. And lastly, there are some protein fibers. Protein fibers you know as maybe collagen and elastin are 2 big ones. Okay, so the ground substance is some non-cellular material between the cells. So it is going to provide consistency. So if we're talking about solid or rigid connective tissue, then it's going to help it maintain its solidification. And if it is something like blood, then it's going to be fluid. So the consistency of the ground substance can change based on, again, the function of the connective tissue. Now you see down here, I put a little note, there are 3 main types of connective tissue. Fibrous, here on the top left, in the middle, supportive, and then on the top right, fluid connective tissue. So in the past, it's been kind of confusing for students to understand that blood and bone are both connective tissue. Well, they fall into different categories: fibrous, supportive, and fluid. So we're going to spend some time and look through these. Now, you know I mentioned that connective tissue is going to have a cell, some kind of ground substance, and then some fibers. So here we go. Collagen fibers, stuff that's underneath your skin, makes it a little taut but flexible. That's collagen. Reticular fibers are thin, highly branched collagen fibers, so they're a little bit more specialized in their support. And then elastin, as you might imagine, elastin or elastic is a type of material that's able to recoil, so it can go back to its original state. So we have these 3 different kinds of fibers that are going to help out our connective tissue. Okay, so we have fibrous connective tissue. And as its name implies, it's made of fibers. We call these special cells the fibroblasts. And they are in a matrix, or they're in this ground substance, just like our other connective tissues. So what differentiates the loose connective tissue and dense? Let's start with dense. When we think of dense, we think that there's a high concentration of something. In this case, it is going to be this fibrous connective tissue. Dense fibrous connective tissue is going to form those pretty rigid, thick structures we call tendons and ligaments. So you'll need to know the difference between tendons and ligaments. Ligaments connect bones to bones. Just think of an ACL connecting your bones of your upper leg to your lower leg. And tendons, like that Achilles heel as a tendon, is connecting the bone of your heel to essentially the muscles in your calf. Now let's go back to loose fibrous connective tissue. There's some in the lungs, for example, areolar connective tissue, and adipose tissue. Adipose is fat. So loose fibrous connective tissue. So now we've learned, okay, tendons and ligaments and fat, and then there's some other specialized connective tissues like areolar connective tissue that is going to be functioning to connect other tissues together and give us support. So this is a really great figure to start to differentiate between types of connective tissue. Let's start with the left side, lower left. we see hyaline cartilage. So cartilage is in those areas like our nose and our ears and between our bones. And between our bones is allowing our bones to move, but also is giving us some bit of cushion between our bones. When that cartilage wears out, we have bone on bone. It's very painful. So here we have cartilage, and hey, look, here's a chondrocyte or a cartilage cell, and it is in this loose matrix, okay? Top left, now we see loose fibrous tissue, so not the dense type, so it's not tendon or ligament, but we see it here in the outside part of this knee structure, and it essentially has got fibroblasts, some fibers like collagen and elastin, okay? So kind of giving us some stretch there. Top right-hand side, another fibroblast, but here we see that we are making collagen, and this right here is an example of that looks like the anterior cruciate ligament. So this is a dense fibrous tissue, and you look at the actual slide of it, and it looks really well developed, concentrated. Next, we have fat. Yes, thank goodness we have fat in our knees. When my daughter was a big time crawler, she had the fattest little knees, and I would try to like kind of keep up with her just for kicks and giggles, and I'd be like, ow, that hurts. But her fatty little knees help her just crawl right across any kind of surface. So fat's got its place. And then lastly here we have bone tissue. So we have the cell, osteocyte, in its little space, and we see that it's all connected together to form this bone. So connective tissues of the knee. Now we want to move on a little bit. So adipose, which is a tissue that stores fat, or we just call it fat tissue, is a loose fibrous connective tissue. Notice it didn't look real dense and well developed like tendons and ligaments, which are dense connective tissue or dense fibrous connective tissue. The main cell of adipose tissue, the adipocytes, these are the fat cells, and they've got the liquid fat, and what they can do is they can lose fat or gain fat molecules or globules, but we never actually lose our fat cells unless you have liposuction. Now, fat is really important because it functions in energy storage, so an on-demand long-term energy for really lean times, but also insulation and cushioning. So again, cushioning our knees. Definitely we've all probably had a fall on our butts, and it was good to have a little extra cushion back there, so it didn't hurt too bad. We didn't break any bones. Fibrous connective tissue, we already talked about. It's actually made up of densely packed collagen fibers, and of course tendons connecting bones to muscles and ligaments connecting bones to bones. Next, supportive connective tissue. So thinking internal support and structure, cartilage and bone. We wouldn't have the shape of our nose or the shape of our ears, or we wouldn't have the cushions between our vertebrae of our vertebral column if it wasn't for that cartilage. And of course, bone. Think about our bone giving us shape to our shoulders, our skull. I mean, so much about us is determined by the bone beneath it. Now we know that cartilage and bone is also going to support the body, and when we start connecting other tissues to it, like muscle tissue, now we can move the skeleton. Okay? Okay. Got lost there on the screen. Okay, so let's take a look at two kinds of cartilage cells. So when we think about cartilage cells, mature cells, they're chondrocytes, and then we have chondroblasts. So chondroblasts are important to making the chondrocytes. There's also another type of cell called the chondroclast, and it's going to break down the cartilage cells. But here you see chondro. Chondro means cartilage, so it's a good way to remember it. And again, cartilage is a little bit different because it has this more flexible nature compared to bone. And then it actually has a little bit less blood supply, so it heals slowly. So if you've ever had a nose piercing, cartilage piercing, then you know how long it takes for the cartilage to heal, simply because it does not have a lot of blood flow. All right, another little blooper here. I ran out of time, so I just